Good afternoon. How's everyone doing? Okay, where's the energy? Go blue. I'm wondering if the rain washed the energy away. Okay, welcome. I'm Jack Hu, Interim Vice President for Research at the University of Michigan. I want to welcome you all to the 2015 Distinguished University Innovator Award presentation and lecture. In particular, I want to extend a warm welcome to a number of guests who are from outside the University of Michigan, who are from outside of Ann Arbor, including our friends from Yale University who are here to talk with us about research, business engagement, tech transfer, and all that. Also, I'm very pleased that President Schlissel is with us, and also President Emerita Mary Sue Coleman, together with King Coleman. I think, where's Mary Sue? I can't see you. Okay, very good, welcome. So the Distinguished University Innovator Award is a very special one. It recognizes activities that the university do in terms of the broader role in business development and engagement with the community. It does more than just teaching and research in our celebration. This award honors faculty who, in the course of their research, who took their breakthrough ideas and then have gone on to translate those ideas into practice. By carrying ideas from concept to practice, these faculty members are going the extra distance to fulfill the promise of their research. They're demonstrating the broader value to society. This is increasingly important because today I think the federal government is trimming research funding. In addition, we have members in Congress who are questioning the value of some of the research we conduct in universities. In this context, it's also important to note that overcoming the challenges of turning scientific discovery into practical product, processes, or services extend our discovery process. By translating ideas and insight into practice, faculty and their students also deepen their understanding of the research discovery and how those discoveries relate to real-world challenge. This, in return, will strengthen a faculty member's capabilities as educator and researcher. But more importantly, I think, is through such distinguished university innovators, we hope to inspire students and future innovators who will follow those innovators in their footsteps. This helps nurture the spirit of creativity, teamwork, innovation, and entrepreneurship throughout our communities and beyond. It was this commitment to the role of the university that by strengthening such a role that we can create bigger impact to society that led to the creation of the Distinguished University Innovator Award in 2007. By honoring those who have shown leadership in innovation, we hope to encourage more faculty and more students to explore the implications of their discoveries in the labs. To do this, we ask our winners each year to tell us their stories, what it takes to turn discoveries into product, process, and services that will benefit society. That's why we're here today. Today we're honoring a very special person, Professor Steve Forrest. As many of you know, Steve is an extraordinary person who has done extremely well as a researcher, whose scientific research led to many discoveries, and they are fundamental discoveries. He's also a very successful inventor and innovator, and also a mentor to many students and postdocs. Steve received his bachelor's degree in physics from the University of California, Berkeley, his master's and PhD from the University of Michigan. He's currently the Paul G. Goebel Professor of Engineering, Professor of Electrical Engineering and Computer Science, Professor of Physics, and Professor of Material Science and Engineering. I don't know how he put all those on his business card. Early in his career, he worked at the Bell Labs, was on the faculty at the University of Southern California. He then spent 14 years on the faculty of electrical engineering at Princeton. In 2006, he returned to the University of Michigan to serve as the vice president for research. Along the way, he also maintained one of the largest ongoing research programs in the College of Engineering. Just over a year ago, he stepped down after 8 years of serving as the vice president for research to devote full attention to research. Over the course of his career, Steve has achieved worldwide recognition for groundbreaking work in physics and material science that has laid the foundation for many different innovative applications, such as fiber optic communications, imaging arrays, illumination devices, photovoltaics, and screen display. He is particularly noted for his pioneering work in the use of organic materials in electronic devices. Steve usually jokes with me, if I take out my Samsung cell phone, he will be very happy because some of his inventions are licensed to companies that are in your smartphone devices. First and foremost, Steve is a scholar. He has truly a remarkable career in terms of the fundamental research in materials and physics. He's the author or co-author of more than 560 papers, and his papers are cited more than 86,000 times by Google Scholar. That's a big number. Steve is also an innovator. He has long been dedicated to translating his fundamental discoveries into practice. To that end, he holds 271 patents, and 95 of those have been licensed to companies around the world. In addition, he has helped fund 5 different companies. NanoFlex Power Corporation, his most recent adventure, is aimed at commercializing ultra-high efficiency thin film solar cells, as well as cells made of organic materials that are flexible enough to be able to apply to surfaces of different contour and shape. A distinguished researcher from the UK, in fact, the University of Cambridge, provided the following accolade for Steve. Steve's breadth of understanding covered the entire gamut from the fundamental to the practical, and he has had an astonishing striking rate in finding winners. Quite a number of home runs. Throughout all those, Steve has been an inspiration to his students and postdocs. Over the course of his career, he has mentored 52 PhD students and 27 postdoctoral fellows and research scientists. Many of them have gone on to be leaders in academia, industry, and being entrepreneurs. As vice president, Steve took the opportunity to improve the culture of entrepreneurship and innovation on the campus of the University of Michigan. Through the development of the Business Engagement Center and the Venture Center in Tech Transfer, his involvement in Ann Arbor Spark and many other activities in the community, he played a key role in strengthening the support for faculty interested in entrepreneurship and in working with companies. As our colleagues noticed, the past 3 to 5 years, we have seen a major change in the culture, how faculty translate their research and then encourage their students with innovation and entrepreneurship. I think Steve had a lot to do with changing that culture. In fact, it was Steve who created the Distinguished University Innovator Award in 2007. The idea was to recognize innovative faculty members who could serve as role models for other faculty and students. It is especially appropriate for us to recognize Steve for the Distinguished University Innovator. So please join me in congratulating Steve for his achievement in scholarship and innovation, as well as his commitment inspiring innovation in others. Steve, please.
Thanks, Jack.
So I'm very pleased that President Schlissel is with us, and he's going to do the honor of presenting Steve the award.
So the idea behind this award it really speaks to a value that we share here at the University of Michigan. We're here to serve the public. We create new knowledge, we teach, but part of this is getting that knowledge out to the public in as many ways as we can, in ways that are useful and that improve society. So the Distinguished University Innovator Award really speaks to that value. And I certainly can't think of anyone more deserving than Steve, and I was also going to compliment the person that thought of this idea, but I can compliment Steve for that as well. So Steve, as Jack mentioned, is obviously an outstanding scholar, and if that were all he did, he'd be amongst our leading faculty. He's also a wonderful servant of the academic community, his many years in the Fleming Building and leadership position and other positions around our town and community. But he's almost the definition of an innovator. He invents things. He takes what he's learned and discovered and uses them to solve practical problems or to really make people's lives better by transferring that knowledge off into the commercial sector. Just listening to Jack's introduction, I would have thought that we didn't really need a big investment in our IP office because we just could have hired Steve and hold on to his patents and his licenses and we'd be done with it. I'm only kidding, Steve. But beyond modeling this behavior, I'm sure he's inspirational not just to his students and postdocs and others in his department, but his faculty colleagues as well. So on behalf of the University of Michigan, I'm really honored to present Steve with the Distinguished University Innovator Award, and I look forward to hearing his talk.
Thank you. I'll get like this. Thank you.
Steve, we also have a check that is to recognize your distinguished scholarship and innovative activities. So,
Thank you.
you can have a nice dinner.
Yeah. I'm going to be giving it to Roz.
So now I think I will turn the mic to Steve. He will tell us his experiences. The title of his talk is Academics Adventures in Business.
Thanks. Thank you, Jack. Thank you all for coming. It's really quite an honor to be here and to be given this award. I have a lot of friends here, and they've come from some distance. You'll be hearing about many of them during my talk. But being a professor who also has some ability and opportunity to work with the outside world is really the best job in the world. That's really what it comes down to. And I've had the best job in the world that every morning I get up and I can't really believe I get to do this. I want to take you 30 years down a rabbit hole. It's an academic's adventures in business land. I changed the title just slightly. And I want to talk to you not about business so much as about people, because nobody does this alone. Just like everybody who is a professor has a group of students. I have a fantastic group of students. You'll hear about some of them. And in companies, nobody does it alone. And I'm going to talk about that. So I'll just open up by talking about some of my experiences and then the lessons learned. And then I'm going to talk about people who've had very significant impact in me over the years. And then at the end, I want to really close by talking a little bit, because I was also an administrator, as you have heard. I want to talk a little bit about what's going on in the US and why we're good at this and what we need to do to stay good at this. So you've heard my history. I don't need to go over it again, so we won't. And I'll leave it at that. I want to start with, I'm going to really talk about 2 companies, and I've been involved in 5, and that was really the point of that last view graph. I'm going to talk about 2 in particular, and then maybe make some allusions to some newer companies that I'm working with. But it really started with my life at Bell Labs, which I was right out of graduate school at the University of Michigan, and got into this thing called lightwave communications before anybody really knew what lightwave communications was. And that's fiber optics, for those of you who don't know. And my first project was to sort out why we couldn't have a long wavelength photodiode for this technology, which was very important. At the end of every fiber is a photodiode. And they were dying like flies, and they weren't very sensitive. And out of that came an invention, which is this, what's called a PIN photodiode. It uses a material called indium gallium arsenide. So it absorbs the light and turns it into electricity that we have in our fiber optic communications. In fact, this exact device is used in every fiber optic system in the world today. Every time you pick up a phone, you will be talking into one of these photodiodes. Bell Labs was a rough and tumble place. It's really sad that it is gone, but after you get put into the washing machine and tumble dried a few times, you start to think there must be something more to life than getting beaten up every day. So I started to look at going to university. Little did I know that all they did, it's just the velocity of the tumbling is different, but you still get tumbled. So when I was looking for a job, this guy who I would call a friendly competitor, who you will hear a fair amount about today, Greg Olson, and his friend, Vladimir Balin, they're both here in the audience today, were starting a company, and they wanted me to join the company too. They were a little late on the pickup because I had basically decided I was going to go to University of Southern California. But as things would have it, Greg is a very, very persistent person. And he insisted that I work with him anyway. So I said, well, I probably can consult. And so I used to fly out back and forth to Epitax. The founders of that company are really Vladimir Bond and Greg Olson. And we worked on these photodiodes as for fiber optic communications. I couldn't tell them how I did it because it was at Bell, but they learned through little instructions from me and so on. And we got a company going, and it was quite successful. And that sold, that sold in 1990 to Nippon Sheet Glass, and got a little money out of that, and Greg decided he wanted to start another company, but he had a real problem. He didn't have enough money, and he didn't have a place to do it in. And so he worked on a very difficult subterfuge, which was tried to get me hired at Princeton, something I really had no interest in. I was very happy at USC, but my wife Roz was not so happy. I don't have enough time to talk about how that happened. It took a period of a couple of years, but I got to Princeton. We had what I call the great existential discussion of my life. It was at, I think, the Holiday Inn in Los Angeles or Pasadena. And Greg said, you know, if you come to Princeton and if I start this company, Sensors Unlimited, will you work with me on photodiodes for imaging? And the reason it's exponential was my answer, which is if I go to Princeton and if I'm allowed to, yes. And if I have space, yes, we will work on this together. And we just put it together. Sensors Unlimited was the first company that ever got an involvement with Princeton in a really hand-in-glove fashion. I convinced the people there to do that, the organization, and they said, well, we'll try it. We'll see how this thing works. And we started making imaging arrays for cameras. I had a student at the time at USC Yue Liu, and we put together these avalanche photodetectors, which are very, very sensitive. And these went into the elements of cameras. So here I am working in the quintessential Ivy League school, which is really basically truly a humanities-based school. Engineering is not on the high, although they have lots of engineering students, was not really high on their list. How are we going to communicate back? Well, it's kind of funny. We got a call. We had these infrared cameras. Marshall Cohen, he was president of Sensors Unlimited, took one of our cameras, got a call from the Phillips collection in Washington, D.C. And this is this beautiful Renoir painting. It's the prize of the Phillips collection. And Renoir took, I think, 10 years to paint this thing. And there's lots of stories behind it. So they knew there was an underpainting. And our cameras could look through the painting, and we could see this was his girlfriend, and he moved her face. This was actually his banker, venture capitalist. And they worked really well together for quite some time, except the venture capitalists, as they do, got impatient. And they got into a big argument. So you can see from the underpainting that the venture capitalist slash banker got turned around and now forever looks out. And Harold Shapiro, who came from here as president, and then he went there, started to use this as the connection between the marriage of technology and art. It was written up so many times in the local newspapers, this story. It came back and forth and back and forth. I had a newspaper on my desk in my office, and one of our French professors in our department, Antoine Kahn, a good friend of mine, said he saw yet another article on this, and he says, "Steve, finally, somebody has made Renoir famous." Greg has a friend, Stuart Johnson, from the Johnson & Johnson company. He's a very famous sculptor, and he then put together this sculpture, which is out in the Trenton Sculpture Garden. So everything comes around in this great circle. This is kind of the resume. We call it Sensors Unlimited Boom, Bust, and Bounce. So it started with Epitax. It got sold for $12 million to Nippon Sheet Glass. It then turned over, long after we had departed, to JDSU, and had 1,000 employees. This was a really big event for me because I felt that my group had participated in all of those livelihoods in some form or other. Then Sensors Unlimited was founded in '92. It got sold at the height of the internet boom for $650 million to Finisar. But of course, there was a crash, and we then were able to buy it back for 1% of the sale price. Greg and I used to go out to beer every Friday at a bar called the A&B. And it was getting more and more glum because we knew they were going to shut down Sensors Unlimited. And we sat on these high stools. I remember this to the day. And we just knew that, I think in like August of 2003, they were going to shut the thing down. And Greg was just down, and he just had a longer and longer and longer face. It was getting kind of unbearable. And then one day he says, "Steve, maybe we should buy it back." And I just remember what happened is I just threw up my arms and I said, "Yes." And that was the beginning of that. And then Greg went into space. The company was more responsible, and it got sold again for $80 million. This was something that Greg and I did. We would go to the federal government and talk about why their investment is really worthwhile. They made $500 million in tax revenue out of that sale, of those two sales. And they invested a lot through SBIR contracts and so on. But that was a huge return, and I think they were quite pleased. I think we did at least 2 or 3 tours to DC together. And this is where Greg went. There's Greg, and there's the Russian captain and an American astronaut, and they got on the top of this. And I have a little video of the launch because Greg had the entire Sensors family come out to, or not the entire family, but quite a few, the leaders and so on, and some of his past friends. We all went out to Kazakhstan to see this thing, and I think it was my student, Chris Dries, who took this video, which I have to tell you, I never get tired of watching. I've only seen it about 1,000 times, so. horsepower can't be wrong, is what we said. You could hear somebody say, "Go, Greg, go." I think that probably was Chris. I could also hear Krista, Greg's daughter, take in her breath. Oh my God, what's going on here? So Greg spent 11 days up there, did some nice programs back down to Earth, and one was at Princeton University, which filled up the auditorium there. But let me tell you, if this ever happens in your life, you never forget it. We're at about 800 meters away from that guy. It was just amazing. So, like I said, I've seen it many times. You can see why. So let me just go through one other company, which is Universal Display Corporation. In 1987, these two guys, Ching Tang and Steve Van Slyke at Kodak, came up with a really revolutionary device, which was this OLED. They didn't call it an OLED at the time, but it's an organic light emitting device. It's only about 1,000th of the thickness of a human hair, and if you put a little current through it, out comes light, and they got some green light, and it was about 1% externally efficient. Wasn't very efficient, but it really woke up the Japanese, who thought, there's a display industry here. And in fact, this turned into a display industry, but not before something else happened. This was very inefficient and couldn't really cover much of the spectrum. But if you think about how a display works, and basically you're looking at pixels, red, green, and blue pixels that are very closely spaced, and you see the full color. Your eye does a little bit of synthesis with the colors, and you see the color that you want to see. And so to make a display, you just change these molecules. They're organic, which means they're largely carbon-containing, as opposed to regular semiconductors like silicon, which is just silicon. But here you have mostly carbon-containing materials, and this is just the stick diagram of that. And each vertex here, you have a carbon atom, and you have some other atoms going on in there. And by changing the chemical structure very subtly, you can get all kinds of colors out of this thing. And so if you put red, green, and blue pixels together and space them very closely, you put some current through it, you have a really beautiful display technology. What everybody has, most of you have today, are thin film transistor liquid crystal displays. And basically that's, you take a molecule, and by applying an electric field, you can basically turn the light from a light bulb and back from on to off, and you then have some color filters. And you get the colors you want that way. So this is a subtractive, if you like, a subtractive coloring, which isn't very pretty. I know we're very used to LCD displays, but they're not very pretty. And these are very brilliant because they light up, but it's very inefficient. Well, got together with Mark Thompson, a professor at the University of Southern California, and my student, Mark Baldo. We're now at Princeton. And we looked at this problem. And we thought, how do we get 100% efficient light out of this thing? Because these things are going nowhere unless we can get 100% efficient light. It turns out in chemistry, it's a very simple trick that you put in a heavy metal into the center of this molecule. You noticed before it was aluminum, now we've got iridium or platinum. And independent of all this, it's basically a quantum mechanical trick that allows all of the electrons that go into this molecule to give off light. And so now we have a 100% efficient device, if we could actually make this thing work. Well, we made it work right away, as it turns out. We bought off the shelf, platinum octethyl porphyrin. It wasn't the best stuff, but it was red, and it was a little slow. And then Mark started to engineer these iridium complexes. That was Mark Thompson, and Mark Baldo, my student, figured out how to make a very high efficiency device. And all of a sudden, we have every color on the palette across the color gamut. This isn't coming out very well because this is actually a liquid crystal projector. Yick. You have to admit, it's pretty lousy. These things are fabulous. It's like, these are 1 centimeter, we call them coupons, so they're just 1 centimeter OLEDs. And you can see just by changing subtly the chemical composition all the way down from the deep red to the deep ultraviolet, by getting a blue, red, and green OLED sitting side by side very close, we can make a display. And that was not the genesis of Universal Display Corporation, which we had started earlier, but this was the invention that really made it go. And I'll talk about a little bit about the people involved in that in a minute. Oh, and by mixing those colors, you can get white. Okay, so what happened? This is me, not Vanna White. Right now, that little quantum mechanical trick, among a whole bunch of other patents and ideas, has turned out to be at the very core of a $15 billion display business, which is growing like crazy. Success is basically based on the inventions at UM and USC for 100% triplet emission. Now the Japanese, and particularly the Koreans, got really excited about this. We actually founded UDC in 1994 based on this guy Sherwin Seligson. Oh, I'll talk about him in a little bit, so I won't do it right now. But it went public at an incredibly early stage. We had one invention and no good technology, but the street didn't care. Of course, we found out what happened with that. And the market, this is one of the big learning things that you learn, is that it's not about your invention, it's about the market, because the market took till 2010 to catch up, and now it's going crazy. And Julie Brown is in the audience, who's the CTO and VP of this company. So maybe she'll think it came a little bit earlier, but that was when I remember things really took off. And it's profitable in 2012, so it takes a long time. This is the guy that we're most happy with. I like to call this my McDonald's view graph, because there's 750 million of these sold, so it's almost as many as there are McDonald's hamburgers. Actually, there's only 5 billion. They stopped counting. But we'll get there. This is the Galaxy series of phones is the most sold electronic widget on the planet today. And LG is coming up with these beautiful televisions. They have a 55, 65, and 77. I think you can get these two in the States. There's mine in my physics office, and you can see me here and here and here. They're gorgeous. They're about this thick. They're curved. They just look pretty. And you can see a better rendition of this. This was taken with an iPhone or something like that. So you can see how these things look. They are, in my office, people do come by in the hall. This is my physics office, and they say, "What's that?" And then I turn it on, and I get a lot of oohs and ahs, which makes me feel very good. So that's that. Just to show you what the display industry, today LCD is about a $125 billion business, I think. Julie, where are you? Just, you have to nod. But here we're already 10% of that business. One other application, I'm very interested in energy, is in lighting. And these are really efficient light bulbs. I've already said that we get 100% efficiency out of these things. If you really want to save energy and use less carbon on this planet, deal with your lighting. Right now, 30% of all electricity use in buildings and 20%, I think, of all energy goes to lighting. And 80% of that lighting is incandescence. A technology invented 135 years ago. It's about 5% efficient or less, and it is basically a heater that gives off light as a byproduct. These things are 100% efficient. Just think if we could just take a few percent of the use off of the grid for that, how many fewer coal plants we'd have to install, and so on. And it goes into lighting. And these are some really beautiful OLED chandeliers. They're still too expensive to use in the home unless you have some these Acuity fixtures that are used for sconces and things like that. This is all done by Philips and Acuity and who knows who, and this is out of my lab. I love this because this is Jae-Sung Lee, my student, and I was on a lighting panel to assess lighting, and there are all these LED people, and they're saying, OLEDs are no good because they're too dim, and they're too, and we have high power spotlights, and I go back to Jae-Sung and I said, let's see if we can concentrate the light and make a spotlight out of an OLED. He did it in the green, but you could do this in any color. And there he is looking exactly like Shrek. But it's a cool picture. So they can work for spotlights. But mostly it's an area lighting source. And this is at Deutsche Bank. It's really just an absolutely stunning chandelier. What's next? Flexible. This is a 55-inch LG flexible TV. You don't think you need one? You need one. This is something made at UDC. It's just a flexible light bulb. And of course, everybody, the long-awaited iWatch has an OLED display. Mostly long-awaited by UDC because they'd love to have Apple buying all kinds of things that are OLED intensive. Right now, Samsung and LG are the big manufacturers, of course. So I want to talk a little bit about what does founding a company mean, because I think it's an overused and misunderstood term. And I just use this, the UDC story, because I think it takes a village. You need ideas. There are certainly founders. That's Mark. I don't know who this guy is. Then there's Sherwin Seligson. He's the guy who came into my office in 1994, and I had a moth-eaten OLED. It was full of holes. It was ugly as can be, and it was green. And he looked at it and he says, "Steve, you've invented a new form of light." I have no idea what that meant, but he was really excited, and he started to do some angel investing with his friends. And so I would say I would credit him with gathering the money and with having the inspiration, the vision thing. And then it takes, now these guys came in a little bit later, but it's equally important. It's enterprise building. You can have any idea in the world, but it doesn't make anything of value to people out there as a product unless you have people who are committed to it. This is Steve Abramson and Sid Rosenblatt, who are kind of the managers of the company, and then Julie Brown, who was my fourth PhD student, who was looking for a job out in New Jersey because that's where she came from. She was living in California at the time. She gave me a call, and I said, well, this is a really bad deal, but why don't you try checking out these guys and see if you can make a run at it? And she did. And she's been the CTO ever since and has done a spectacular job in bringing this technology to the marketplace. And of course, you need markets. And of course, that you can't predict. And that came rather late, and we had to be at this rather long. But there you go, LG. So this is what I learned. And I'm going to shift gears radically. Building a company is done brick by brick. Like everything good in life, there simply are no shortcuts. There is no way to not call the right person. There's no way not to get the right experiment done. There's just no way not to get everything done exactly in the order that it needs. You have to do it, and you have to stick with it. This is, Sherwin would always say, Steve, he's a New Jersey guy. I got to do this. Steve, starting a company is all about slaying dragons. There's so many of them, and you got to kill them one at a time, because if you don't kill them, they'll eat you. And I think that was good advice. They multiply faster than rabbits. Use every available resource. Doing it yourself sounds good, but usually leads to disaster. And use the universities as much as possible. Don't worry about an exit strategy, which is what Alice was doing there. As I would, almost as soon as you get involved in something, somebody asks, "What's your exit strategy?" And I would always say, "It's not about my exit strategy. I'm still working on the entrance strategy." Your technology is not nearly as important as your markets. No idea is good enough to be ahead of its time. So many things die by being ahead of their time. And as inventors, we love our inventions. We think they're just the greatest thing possible. But really, there is no such thing as being successful if you're too early. Inventors can make lousy CEOs. Pick a single career and go with it. Be a professor or be a CEO. When I would bring up this sort of decision-making process to Roz, my wife, I say, "Roz, maybe I should be the CEO." And she says, "What do you want to do? You want to fill trucks?" And so I said, "No." All right, so stick to your knitting, So pick a career. And I've never seen a good professor who was also a good CEO and vice versa. You really have to do it one way or the other. And this is something that took the longest to learn. Companies and their founders' interests eventually diverge. A company grows up. We don't. Accept the inevitable. Accept the inevitable as gracefully as possible. I can tell you how many tough days I've had with that. Always work with friends. And required viewing is the Treasure of the Sierra Madre. So I'm going to show you 4 brief clips from the Treasure of the Sierra Madre. How many people have seen that movie? If you haven't, there's a very big missing element of your life. So I'm going to do 4 lessons from the Treasure of the Sierra Madre. This should not take longer than 5 minutes in total. The first is about finding money. So this is it's really a very dark tale about greed and what happens by these down and outs in Mexico. One of them is Humphrey Bogart. So here you'll see him looking for his first venture funding. Oops, no. Let's see if I have to do it this way.
Say, buddy, will you stake a fellow on?
See, that's me looking for money. Another company gets it.
Hey, mister, will you stake a fellow American to a meal?
Such impudence never came my way. Early this afternoon, I gave you money. While I was having my shoes polished, I gave you more money. Now you put the bite on me again. Do me a favor, will you? Go occasionally to somebody else. It's beginning to get tiresome.
Oh, excuse me, mister. I never knowed it was you. I never looked at your face. I just looked at your hands and the money you gave me. Beg pardon, mister. I promise I'll never put the bite on you again.
This is the very last you get from me. Just to make sure you don't forget your promise, here's another peso.
Thanks, mister. Thanks.
But from now on, you have to make your way through life without my assistance.
You don't you have bad luck rest of your life.
Wait a minute. What'd you first say?
Well, he's trying to tell you I sold you the winning ticket.
Hey, wait a minute.
Now he wins the lottery.
Is this what you mean?
Si, senor.
You say it's a winner?
Si, a 200-peso prize.
Where?
3721.
Hey, that's my number.
Sure enough.
Oh, just look at that fat, rich printed number. That.
So now he's off. He's got his company going. He's got his money. Now he's going to go out and stake a claim, but he's got to figure out how to do that. And here's something I actually learned through Greg, is don't get too greedy, and timing is everything. So they're in a bunkhouse deciding what they want to do. There's an old timer talking about finding an ore of, he's an old prospector.
Gold's a devilish sort of a thing anyway. You start out, you tell yourself you'll be satisfied with 25,000 handsome smackers worth of it. So help my Lord and cross my heart. Fine resolution. After months of sweating yourself dizzy and growing short on provisions and finding nothing, you finally come down to 15,000, then 10. Finally you say, Lord, let me just find $5,000 worth and never ask for anything more the rest of my life.
$5,000 is a lot of money.
Yeah, here in this joint seems like a lot, but I tell you, if you was to make a real strike, you couldn't be dragged away. Not even the threat of miserable death would keep you from trying to add 10,000 more. 10, you'd want to get 25, 25, you'd want to get 50, 50, 100, like roulette. One more turn, you know, always one more.
It wouldn't be that way with me. I swear it wouldn't. I take only what I set out to get, even if there's still $500,000 worth lying around waiting to be picked up.
You'll notice he's drunk when he says that. Okay, and then of course you got to watch out for the competition. Sometimes they come in the guise of the IRS or somebody else, and they want to get...
Oiga, señor, we are federales, you know, the mountain police.
If you're the police, where are your badges?
Badges? We ain't got no badges. We don't need no badges. I don't have to show you any stinking badges.
So it's all about slaying dragons. So the last one I'll show you is, so they go off, and of course they're completely brought down by greed and horrible things. And, but that's not really the point. I want to show, this guy, the Bogart character, finally gets killed by some banditos, and the gold in the bags is dropped on the ground. And his two partners go riding off to find the gold. And you'll see the gold, because it's black and white, it'll just look like piles of sand blowing away in the wind.
curtain, old boy. It's a great joke played on us by the Lord or fate or nature, whatever you prefer. But whoever or whatever played it certainly had a sense of humor. The gold has gone back to where we found it. This is worth 10 months of suffering and labor, this joke is.
Anyway, that's what I learned. So let me just go through a few things because it was really about people and it's about mentors. And I want to mention 3 people who are very, very important in my life. One, of course, is Greg. He's, as you could see, put himself on the top of that rocket. He's an adventurer in every sense of the word. And what he really taught me were the 3 words below, which is how to focus. Absolutely. If I lost focus, he was really quite difficult to deal with. He has incredible integrity. It's just, everything's got to be, again, just so. I guess he told me, Steve, you got to talk in bullet points. You're an engineer, talk in bullet points. So he wouldn't be enjoying this so much. And sharing. And if you do that, you always win. And like any guy who's been spending too much time in industry, he kind of listened to the sorts of things that Jack was saying initially. And he said, how many damn titles do you have anyway, Steve? But this was also a pretty good piece of advice. And I was down in the dumps and worrying about one of my companies that wasn't going in the right direction. And he said, don't worry about it, Steve, let it go. This was also at the A&B bar. You have plenty of ideas for the next company. And that was really good advice. It was ASIP, that was the company. And it just allowed me to move on. And I think that's always good advice. This is Sherwin. He's a protagonist in his own novel, we like to call him. He's a born and bred New Jerseyite. And he has this thing, he says, Steve, it's all about the mysterium. You have to figure out what a new form of light is and what the mysterium is, but this man has vision. And he showed that you could actually have just a really far out vision and bring it to life as long as you could slay dragons. And then finally, Mary Sue Coleman, who's in the audience here, she really taught me, I always thought that things kind of happen by chance, sort of. I mean, they get a little push, and I've always been subjected to good leaders. Greg has been a fabulous leader. But she showed me how incredibly important leadership is. And she wrote this little piece and gave a speech, Partner or Perish. And it told me, this was before I came, that she truly understood what the community was between industry and academia. Her form of leadership was to give others enough rope to hang themselves and then hope they don't. And if you did, well, I guess somebody's gonna have to clean up. But that's kind of, I think that's a good model. I think that's a very good model. Give people room to play, and that's the only way they're going to grow. And the other thing she said was to Steve, check out what they're doing in Israel. She wanted to figure out if there was stuff we could bring back to the US. So my last little bit will be simply about talking about the innovation ecosystem that exists at university and how the University of Michigan, I think, has really taken a leadership role in this. And I just listed the sorts of things that I worked on. I know that Jack has worked on and people before me have as well. But certainly this lecture, in a sense, is an indication to other people, an opportunity to see that this is something that the university values. And that's important if you're going to keep doing this. Ease the pathways to success with our Office of Tech Transfer, with the Business Engagement Center, with the Venture Accelerator, for example. All those were put in. You never know what's going to work. You have to be very entrepreneurial about it. Just throw a lot of things in and see which ones take. Mentors in residence. Establish policy that reward engagement. Keep the contracting system simple and transparent. Work with the royalties to make sure they return back to the inventors and to the departments. Have visible players like Mary Sue and President Schlissel to highlight the importance of this to the mission. Create community support through Spark, MEDC. Manage conflicts by forming true partnerships. I don't want to go too much further, but I did go to Israel, and it made me think a little bit. And I gave a talk in Israel, a couple talks in Israel. If you think about the innovation ecosystem in the world, the United States is up here. It's well beyond where other countries are. And Israel is kind of in the middle. There's nothing between us. There's a huge gap. And below Israel, there's another huge gap, probably the UK or maybe Canada, but it really gets very far down. So Israel and the US are definitely the most entrepreneurial, innovative countries in the world. And I started to ask myself, why is that? And I just made some lists here: tolerance for failure, diversity of population, availability of capital. It's okay to question authority in the US. It's absolutely imperative to question authority in Israel. There's something wrong with you if you're not. Many success stories, very important. Cultural imperative to thrive. We like winners in America. There they have a pressure cooker environment where if they don't perform, everything could collapse around them. So there's a cultural imperative to thrive. Robust university-industry partnerships. In Israel, when I came back to report to Mary Sue, she says, well, what do we have to learn? And I says, well, not a lot, because they do it so differently. But obviously, I have learned a lot. But their military is the common form of innovation there, and where our universities have really taken that role. And we have a vast market access. The challenges, the government drag, weakening of the funding base. There they have national security. They have a war about every 6 months to 2 years. We have a troublesome immigration policy, which is really hurting the feedstock of all of our innovation, is our immigrant population. They have a demographic problem, which I don't want to go into too deeply, but basically 50% of the people do 100% of the support of the society, and that can't be sustainable. We have an eroding manufacturing base. They have a limited pipeline because it's a small country, and so on. So with that, the bottom line, in the post-Cold War, post-large industrial lab era, universities and industry share a common destiny in this globalized world of science. We just simply can't succeed without each other. And I've been really fortunate to be able to be part of that, and I continue to be so. So I want to thank a few people here. Roz, my wife, for God knows how many years. She calls herself a physics widow. Those of you in physics know what I'm talking about. My friends call her the saint, because she has to live with me. And to me, she's just been a constant inspiration and supporter through all of this. And then my group, the Optoelectronics Components and Materials Lab. This is the existing group, more or less, plus or minus a couple, because they come and they go. Maybe everybody who is one of my students now or in the past would stand up just for a minute. Now, if you want innovation, these guys are innovative. They're amazing. And we have a culture of innovation in the group. I think it's really fun. Everybody gets a really big kick out of coming up with something new, and it's roundly supported. These are the companies I've been involved with. You've heard about these three. ASIP I didn't talk about. It's a really great company. They make millions of parts every year, but they're now part of Avago Communications. And Nanoflex is the latest experience that I'm having in thin film PV. And like everyone, this is very new, and it's a really exciting company, and we're out there busy slaying dragons, and I'm looking for a great future for that company too. So thanks very much.
Steve, so maybe we can take 1 or 2 questions. Do we have questions?
There's a question back there.
Okay. Can you speak loud enough?
Sure. Thanks for your talk. You mentioned that the university and industry have changed
Well, I think today universities play one of the very most major roles in innovation. So there are some great big companies out there that are innovative, but they're not looking very far over the horizon. If you want something that really changes the world, it has to start at a university, almost by definition. That used to happen at places like Bell Labs or Xerox and so on. But today that sort of innovation is happening at the universities because those large labs have more or less evaporated everywhere. So if you really want to do something that is extraordinary, not have somebody telling you you've got to make this quarter's budget, et cetera, the universities are where that's happening. And I see that continuing. I am very concerned about where the federal government stands on this, but I've been around long enough to know that these things go in cycles. And I think in Washington, even though you hear an awful lot of noise, there is a fundamental understanding in this country that innovation is what has driven our economy for the last 70 years. It really has been. Commoditization is not something we do well. We innovate, we spin it off somewhere else to make large quantities of whatever it is that are being made, but we constantly come back and innovate the next thing. Anything with high intellectual property content, the United States is peerless in that, and I think the universities sit at the core of it. And one hopes that the government will not completely blow it. I don't think they will, but we worry about it, and places like the University of Michigan have a very strong voice in Washington to make sure that this boat keeps sailing forward.
Okay, one more. Come on.
You are a physics major, right?
Yeah.
You must have also discovered the issue of time dilation, because we're wondering, how can you do all of these things? So could you enlighten us with that?
Well, time dilation works good if you're moving really fast. I don't know. I think the most important thing to do is just, if it lands on your desk, get it done right then. If you let it pile up, you're dead. But, it wears you down, too. And so you have to take breaks. And I think one of the things that I take the most pleasure from is I really love the arts. And it gives me some time to just let my brain cool. And so you have to have a way to retract and get out and then come back in and keep diving back and forward. And everybody needs Roz.
Okay, thank you very much, Steve. So we have the refreshments waiting for us outside, but before we do that, I want to read part of a letter from Governor Rick Snyder. After he returned from Portland to Ann Arbor, he was chairman of Ann Arbor Spark, and Governor Snyder worked very closely with Steve in creating an entrepreneurship community in the area. This is just a paragraph. Steve, as you receive this award, I encourage you to reflect and take great pride in this accomplishment. Recipients of this distinguished honor embody the vision, leadership, and determination that are critical to transforming our economy, preserving and improving the quality of life for our citizens, and reinventing Michigan. You have demonstrated ultimate creativity and innovation. I look forward to seeing all that you will accomplish in the years ahead. Thank you for your service to Michigan. So finally, I want to thank David Lempe for organizing the nomination process and also the selection process. We have a number of committee members who helped select Steve as the winner of the Distinguished University Innovator. And also for Nisa Turek, who organized the event. So thank you all for your help. So the reception is outside. Keep the conversation going. Thank you all very much for coming. Yeah, congratulations, Steve. Yeah.